Ajax is this week, and you want me to make an ML model for us? Nah, dude, don't worry. I know exactly how to prepare for this. Introducing MonkeMon, an educational game that makes ML accessible to beginners with little to no experience. It takes core concepts of ML and effectively abstractifies them to enable kids to learn their meaning and importance without dealing with the complex math and programming. Here, we demo the first level of this game, where our monkey, Monke, has to travel around the jungle and collect data on the various animals. His goal is to make an ML model capable of classifying a particular animal as a mammal, reptile, amphibian, or bird based solely on their color and weight. As he collects data, his Monkedex is populated with information about the animals he's met. So here we see the Monkedex, and we can click on a particular animal, such as a hippo, to see information about that animal. All the while, a timer is counting down, as you can see in the top right, and the Monke has to collect data and train his model before the timer expires. This forces the player to balance the amount of data, the quality of the data, and the model complexity as a way to represent limited computational resources. We built this project using C# and Unity with a Flask endpoint backend running Python code. The backend uses libraries such as NumPy to handle vectors and matrices. The game makes a request to Flask at the beginning to generate randomized animals based on real distributions and spawn sprites for each of these data points. As data is collected, which is addressed by collision detection that triggers dialog, our custom data structures update to accommodate this data. When the player has collected enough data, they can choose to train a model and pick their classifier. A post request is sent with their data to the endpoint, which uses sklearn and matplotlib to return a plot of accuracy versus some parameter, such as number of nearest neighbors. In the future, we want to add levels that require the player to be involved in feature selection, more diverse algorithms including regression models, more sophisticated algorithms such as neural networks, and parameter optimization. We wanted to start at a level that was comprehensible to kids of all skill levels before slowly ramping up the difficulty of the gameplay. To complete each level, the user would have to produce a model that meets the accuracy threshold for that level, and as the user has to balance more and more factors, it would become more difficult to meet this threshold, given the time constraint, which reflects the computational resources available for data collection and analysis. We hope you enjoyed our demo of MonkeMon.